Hello and welcome to the Further Maths videos for OCR Pure Core. This is Vectors 4 Equations of Planes and video 4.2 the equation of a plane using the normal to the plane. So we've seen previously how to write the equation of a plane using parameters, and now we're going to use the normal, which is something that is perpendicular to the plane. In an earlier video we saw that the scalar product of any two perpendicular vectors is 0. This is really useful, and we can use this to define a plane by making use of a vector that is perpendicular to the plane. It looks unusual when you first look at it, but actually once you start to work with it, you can see that you get used to it and it becomes very simple and really useful. So we're going to have a look now at a normal vector to a plane. So every plane has a unique direction that is perpendicular to any line you could draw in the plane. So if we draw a line here, this vector here will be perpendicular to it. If you move it around, you'll see that wherever you draw your line, this is going to be perpendicular. Any vector that is perpendicular to the plane is called its normal vector, and we call it n. We can write an equation for the plane if we know a point on the plane and its normal vector. So if we have a look at this diagram here, we can see that point A here has position vector A. Point P we're going to call some general point on the plane with coordinates x, y, z and position vector r. Now we can see that if we look at this vector here, r minus a, it must be perpendicular to n, which is defined as the normal vector, so it's perpendicular to any line within the plane. We can then use this to write the vector equation of the plane, and we can either write r minus a dot n equals 0, because you know that if you do the dot product of two vectors that are perpendicular, you get 0. Or we can say that r dot n equals p, which is some scalar, and p is the dot product of a dotted with n. So you can see that's just a rearrangement of this equation here. So if we've got a plane with position vector a and normal vector n, the general point is given by this. R is xi plus yj plus zk. And using perpendicular vectors, we have this, our vector equation of a plane. R dot n equals a dot n, which is equal to p, some scalar, when we find out what the dot product is of a dot n. So let's have a look at an example now, because it's one of these things that often seems a lot more straightforward when you get to use it in practice. So we're going to find the scalar product form, or dot product form, of the plane containing this point that's perpendicular to this vector here. So straight away we know that if it's perpendicular to that vector, then n, our normal vector, must be 2, 5, 3. We also know that our position vector A is 1, 2, 0. So now we can use this here to write our equation of the plane. So we have r dotted with the normal, which is 2, 5, 3, is equal to A, 1, 2, 0, dotted with 2, 5, 3. Now we know that if we perform this dot product, we're just going to get a scalar, we're just going to get a number. So we can have a look at what that is, and we're going to get r dot 2, 5, 3 equals 1 times 2, which is 2, plus 2 times 5, which is 10, plus 0 times 3, which is 0, so it is 12. So the equation of the plane is that r dot 253 equals 12. You can see here that working out done. Okay, we're going to have a look at another example now. Now we're going to try and find the vector equation of a plane containing these 3 points, and we're trying to find it again in this scalar product form. So what we're going to need to do first of all is find two vectors that are within the plane, because at the moment we don't have the normal vector. And if we can find two vectors that are within the plane and then find a vector that is perpendicular to them both using the cross product, it means that we can then write it in that form. So if we do PQ is -1, 1, -1, and PT, which is -2, -1, 3. And now what we need to do is their cross product in order to find a vector that is perpendicular to them both. Now, in order to find the cross product, you can either use your calculator or you can use the formula. Oh, -2, apologies. So when we do this cross product, we get 3 minus 1. So we get 3, 1 times 3, minus 1 times -1. 2 plus 3. So we get -2 times -1, which is 2, minus -1 times 3, so 2 plus 3. And then in the bottom, we're going to get 1 plus 2, because we're going to get -1 times -1, which is 1, minus -2 times -1. So we end up with our normal vector being 2, 5, 3, which we know we've seen that previously. Okay, so now we can write this as r dot 2, 5, 3 equals 1, 2, 0 dotted with 2, 5, 3. And when we do this dot product again, we end up with 12, which we've seen before. So that is 12. Okay, and there's that working out a little bit neater. Okay, so thanks for watching, and the next video in this series will be 4.3, the equation of a plane in Cartesian form.